PCSC Film Series presents Kinetic Energy, Elmo's Constant and the Immutable Laws of Science, assisted by Professor Otis J. Fudpucker of the Encino Institute of Technology. This is the Encino Institute of Technology. With the aid of these and many more highly sophisticated pieces of equipment, the students make exact measurements, develop mathematical equations, and unlock one by one the mysteries of the universe by means of the scientific method. Today we shall examine kinetic energy, Elmo's constant, and the immutable laws of science. To lead us through the sinuous pathways in our quest for truth, we have Professor Otis J. Fudpucker of the Institute. Today we are going to discuss kinetic energy and the immutable laws of science. All around us we see examples of kinetic energy. Can you think of other examples? The phenomenon of kinetic energy is present at all levels, even in atomic particles. To show this, we have constructed a model of kinetic energy in atomic collisions. In this experiment, we will use pennies to represent separate atoms. Now watch carefully. Let's see that again. Now we will attempt to verify this model by actual observation of the atom itself. To do this, we will use the microscope. Aha, we see that our model of kinetic energy exactly confirms the real phenomenon in its natural state. Once again, science has uncovered another immutable law. We will now find a precise mathematical equation which describes this phenomenon. To do this, we must delve even deeper into the shrouded mysteries of the atom, and with the use of our electron microscope, we will observe the electron itself. Igor, will you focus it, please? Aha, we have discovered Elmo's constant. 6.38 10 to the negative 4th Newton joules per gram second. Now that we have derived Elmo's constant by the use of this instrument, we can apply our results to phenomena in the real world. Today, my assistants and I will be going on a field trip to Caltech to use their more sophisticated equipment. Won't you come along? Well, here we are. We will now set up our experiment. Firstly, we must calibrate our instrument. Go to it, Igor. Let us investigate the dependence of kinetic energy on mass. We have weighed Igor and Beans and found that Igor weighs 100 kilograms and Beans weighs 50 kilograms. Now up goes Igor, gaining 20 joules of potential energy with every step he takes. My assistants here are setting up a device which will allow us to measure Igor's kinetic energy. Now all is ready. Now we will measure his kinetic energy. This works out to be exactly 100 inches. Now we try the same procedure on Beans. Remember, Beans weighs 1/2 as much as Igor. We measure his kinetic energy and it comes out to be, say about 41 feet 8 inches. This works out to be 500 inches, exactly 1/2 of Igor's energy of 1,000 inches. The experiment seems to be working very well today. Now that we have correlated our field data, we can return to the laboratory and use Elmo's constant. Here we are. We found that 50 kilograms went 41 feet 8 inches and 100 kilograms 83 and 4. Multiplied by 3 the square root of the inverse hyperbole using the third derivative of x sub 1 prime 3 and counting. We now times this by the summation of f equals 1 over f minus x as x increases without bound from here to Chicago. We take the integral remainder of the first order differential equation, remembering of course the Eisenhower uncertainty principle, and taking the matrix of the inverse sum we negate by process of vector multiplication. Finally, by combining the disjunction of the Martin midpoint and the Scardina scalar, and by process of elimination, we end up with one hell of an equation. Now we simplify the equation by cancellation of terms. Ah yes, the terms are dropping out like flies. Leaving us with 1/2 mv squared. To review our experiments, we set out to investigate kinetic energy. Using liquid kinetic energy, we discovered with the microscope that our model confirmed the actual actions of atoms in nature. Having discovered Elmo's constant, we went to Caltech and discovered the relationship between mass and kinetic energy. Using higher mathematics, we uncovered another immutable law. Turning back the clock to the dawn of time, we see that primitive man did not understand the real world. He reacted with ignorance, superstition and fear to simple scientific phenomena, such as playground slides. He explained everyday occurrences in terms of magic. The ignorance and superstition of prehistoric times were soon to be replaced by the Dark Ages and the Age of Faith. The Age of Faith was dominated by the medieval church, a church that stifled wisdom and science. It taught men to look upon this world as a place of suffering, a vale of tears. Men were content to ignore the things of this world and to look towards heaven and the afterlife, of which incidentally is absolutely no empirical evidence. Virtually no aspect of life was left untouched by the church. It made no attempt to understand natural phenomena such as kinetic energy, but rather accepted it as a matter of blind faith. Fortunately for us, the medieval church faded into obscurity. out of the darkness came science. And today, men of science stride fearlessly in a glorious march towards truth and endless progress. Unlike the savage who reacted with ignorance and medieval man who reacted with blind faith, the scientist reacts to phenomena with understanding.